We're in lesson 2 of our irrigation unit. To know anything about irrigation, you need to know about the water cycle. You've probably learned about this in elementary school, right? You learned about how the water comes from the sky, the clouds, and then it goes down various ways into the water systems, and then how it goes back into the sky and the clouds. Remember, it's a circle, it's a cycle. So look at this. In a little bit more detail than you did in elementary school. So you can see, right, the clouds, they're going to hold the condensation that then, remember, when they get full, they turn into precipitation. That's the rain or snow or hail that we get. So that's going to fall down. So it's going to fall down and it's going to create surface runoff, which is water that's running off. It doesn't get soaked into the ground. So this is typically going to go towards groundwater, and it's going to find a system, whether that's a river, a pond, an ocean, what may. Okay, it's going to go like storage as a pond, a river, to the ocean. Then you're going to have some evaporation that goes all the way back up into the clouds from condensation, and it just repeats the cycle. So make sure you understand the water cycle. You need to know that about before you go into irrigation. How much water do we use? So why does irrigation science matter so much? Well, it matters a lot, especially since a lot of our aquifers and large lakes are drying up. It matters more than ever right now. So we need to globally to reduce our water usage. Water's use is a more important factor than climate change because, we can't make any of it, and we absolutely have to have water to live, right? We cannot last more than 3 days without it. Around the world, we use 10,700 cubic kilometers of water per year. That's more than all the Great Lakes put together. So of 100 water basins or bodies of fresh water around the world, quantity of water in half of those has been heavily impacted by human water use. Many more have been moderately impacted, so only a few have not been impacted. So we do use a lot of water. Think about all the things that you use water for, um, not just to drink, right? That's probably the lowest number of what you use water for. Washing our cars, showering, washing our hands, um, using water to fill up, to clean our floors, to clean everything. Um, Water for hydroelectricity. We use water in great detail. So plants need water, obviously. If a plant looks kind of dried up or droopy, they probably need some water. Leaves get water from the roots of the plant, and some of the water is lost to evaporation. So that's why you need to keep watering those plants, because they do lose that water through evaporation. So we call the movement of water through plants transpiration. Plants lose water, and it's called evapotranspiration. So combination of evaporation and transpiration. So it's like when people sweat. When water reaches the leaves of the plants, they lose water to evaporation. This process may not easily be visible as sweat in most plants, but it's always present. So farmers need to understand this rate of the plants they are growing in the place they are growing them. So they need to know the temperature, humidity, wind speed, and typical water usage. Then they can calculate the rate of the crops and respond accordingly. So this allows us to put it to a science and customize the exact amount of water, because we don't want to overwater all these plants, right? Then we're just wasting water if the plants can't use it, if they're just evaporating it too quickly. So that's why it's important to know each plant's needs water-wise. So in addition, water evaporates from the soil. Some of the water in the soil is used by plants, but some water runs off the soil, and a lot of it is lost to evaporation. So right there, that looks saturation, like after a real heavy rain. That's saturated. Damp, we've got that look. Looks pretty wet on top. It comes slightly damp. The soil has some moisture, but it's not saturated. Dry soil. There's no rain. Water table's low. Parched. Okay, if you live in Texas, you probably have seen this in the drought. You'll see all those big cracks and the plants are definitely not getting the water that they need. A single acre of corn transpires between 3,000 and 4,000 gallons of water a single day. That's crazy. One oak tree transpires about 40 gallons of water a year. So plants are using this as well. So you can see all the different sources of groundwater through this map. So we've got a well that's going to the water in the limestone. We've got the water level in the soil, a couple of them. We've got a regular well, another drilled well, and then we've got the rain, groundwater. So transpiration, a number of factors influence how much water is given a given plant transpires. This determines how much water the plant needs to grow and thrive. So these are the factors that affect it. Temperature. So transpiration goes up if it's hotter outside. They cause the cells to open up and release more moisture. It causes them to dry out. This seems like common sense. Relative humidity. As it gets more humid in the air, the amount of moisture in the air, the rate falls because they're in a moist climate. Wind and air movement. So increased movement of the air around a plant results in higher transpiration rate. Okay, they're drying out. Think about you. When do you feel dried out? Soil moisture availability. When moisture is lacking, plants can begin to senesce or age prematurely. Type of plant. Then that's going to vary as well. So the type of plant is going to differ. So like a cactus is going to transpire very little water. They hold in a lot of it. Droughts. You've probably experienced a drought in your lifetime, especially in Texas. Droughts are weather-related phenomena that occur when there's not enough rainfall. They can occur anywhere, and they're typically defined in relation to normal rainfall. So, water is expensive. All these irrigation routes are all expensive, and we don't want to overwaste our water, right? We only have so much groundwater. So that's why farmers can't just keep watering more to make their plants survive. Groundwater or underground water sources like wells contain significantly more sodium than other sources of water. So again, that's not right for the plants. They're going to be getting way too much of that nutrient. So it's very important to understand how water works, understand groundwater, rainfall, transpiration, and know your specific plant and its needs so you're not overwatering and wasting water.